Next, we are going to look at how you can improve the efficiency and performance of your trading strategy with DRL. The application of deep reinforcement learning for trading still remains largely unexplored. However, the promise that this learning strategy has shown in other fields has attracted researchers' interest and focused efforts on the exploration of DRL for trading. For now, the odds that quantitative trading can be disrupted by DRL look good. Some of DRL's advantages include being a good match for a rapidly changing market environment, it having a high potential power and efficiency, and most importantly, that it builds on other machine learning techniques that have proved successful in multiple markets. Financial markets are dynamic structures. Today we have plenty of different types of orders, quantitative trading strategies, new asset classes, technologically enhanced market participants, and many other market variables that were not present a short while ago. Also, the markets of today are very turbulent with increased volatility, lower liquidity levels, and periodic flash crashes. The presence of these factors influences the way we trade, and so results in the formation of short-lived or unique patterns. These patterns are usually very hard to identify in historical data and can also turn out to be irrelevant for the accurate prediction of future market movements. If similar patterns are found in historical data, there is no guarantee that the next time they occur, the outcome will be similar. All this has affected even the most sophisticated fund in the world, Renaissance Technologies. The hedge fund has reduced the use of pattern-based strategies for futures trading in its Renaissance Institutional Diversified Alpha, or RITA, fund by more than 60%. However, RITA still remains way ahead of the competition after the fund gained 3.23% in returns in 2018 when compared to the industry's average of minus 4.75%. When it comes to other trading firms, the truth is that a major part of hedge funds are giving up on trend-following strategies after they've struggled to replicate past returns. In order for an automated strategy to be successful, it has to be flexible and capable of adjusting itself to the present situation and not rely solely on past information, just like their human colleagues do. For now, deep reinforcement learning is the closest thing we have to resemble the way we learn. Just like us, DRL agents learn on the go and by doing. This means that they are getting better at taking real-time decisions based on the specific characteristics of the moment. At its core, learning is an interactive process that requires feedback from both sides. And that is why it's reasonable to expect that deep reinforcement learning agents will become better at navigating financial markets due to their ability to adapt to changing environments and learn from the immediate result of their actions. Financial markets can be considered as a high-density environment because of all the variables affecting the result of a trading decision. For example, even the most basic orders will require the computer to make a set of feasible decisions like price, size, order time, order type, etc. All these factors require the algorithm to make a set of interconnected decisions, such as at what price to buy or sell, and what quantity, whether it should be a single or multiple order at different or the same prices. Should it trade at one or multiple venues? Should it do it one after the another or simultaneously? According to the estimations in J.P. Morgan team's Idiosyncrasies and Challenges of Data-Driven Learning in Electronic Trading study, a medium-frequency electronic trading algorithm will make 3,600 decisions per hour. This is due to the fact that each action is a consequence of a collection of child orders with different characteristics, price, order type, size, etc. What this means also is that financial markets are way too complex for straightforward algorithms as their action space is continuously expanding with all the possible combinations of moves and market characteristics changing all of the time. Existing algorithmic models are designed with two main components: strategy and implementation. The strategy is usually designed by the trader, while the implementation is handled by the machine. In reality, there are autonomous trading mechanisms, although most of them still need some human guidance. Although this may seem like a promising human-machine symbiosis, at some point, a crucial element in the whole system often tends to break down and leaves a lot to be desired in terms of trading results. For example, one of the main challenges is picking appropriate, unbiased, and representative financial data. The inability to do so is often the trader's fault rather than purely a technical limitation. Although the data quality problem is a well-known weakness in the design of efficient trading algorithms, it still remains an issue, and its solution is often quite poorly implemented. However, with the major improvements that deep reinforcement learnings bring, we are getting closer to facing the next level of autonomous trading system, one where the machine is in charge of both the strategic and the implementation parts. Deep reinforcement learning mechanisms, as shown in other fields, can help us construct portfolio management systems with basic cognitive skills that can ensure better navigation in the complex stochastic environments of financial markets. Although way more flexible and powerful, a deep reinforcement learning agent still requires millions of test scenarios to become proficient at what it does. Think of AlphaGo, for example. Also, the fact that these types of agents are closer to autonomy, they still require an operator to assign a reward to their actions, either positive or negative. From a purely technological point of view, the reward part is quite tricky, as it has the potential to become the make it or break it element in the whole system. For example, if you reward a robotic vacuum cleaner with the absolute goal of cleaning your living room, you may end up surprised to find that it has swept all the dust and dirt into your kitchen. What this means is that computers are still far from general intelligence and will continue to require human guidance, even if it is in a more limited form. For how long remains to be seen. But as things stand, we are closer to a fully autonomous trading system than we have ever been before.